All right, good morning, everyone. Today we're going to be talking about congruence and something called CPCFC. We'll explain what that means, so sit tight and wait for that. Our essential question is, what is congruence and how does it apply to figures? Just a heads up, there is a Google Doc on Google Classroom if you want to use that, or you can make your own notes. You do not need a printed copy of the notes today. There are some shapes that you'll need to draw, but they are not on graphs. So you should be okay if you just want to take notes on paper or if you want to use the Google Doc. All right, our learning goals. I can explain why two figures are congruent using rigid motion. I'm sorry, it doesn't say motion there, just rigid transformations. It's fine. I can use the definition of congruence to find missing parts of a figure. All right, so we're going to jump in and we will be covering both of those. The first one you kind of covered in the previous lesson on HMH, but we'll again talk about it today. All right, so right at the top, what does congruent mean? So we're talking about this idea of congruence, and congruent means identical. If I could spell it, that would be fabulous. Identical in form. There you go. So congruent means identical in form. The full definition of congruence, which we are going to use, and this is going to be how we accomplish that first learning goal that says I can explain why two figures are congruent using rigid motion transformations. That comes directly from our full definition of congruence, which you are going to have to know. So here's what it says. It says two figures are congruent when there is a sequence of rigid motion transformations that move. Oopsie, starting to get ahead of myself there. Fix this while I'm at it really quickly. One figure onto the other. All right, so again, two figures are congruent when there is a sequence of rigid motion transformations that move one figure onto the other. So we have seen this already when we were doing kind of that game called Shape Mods, where you had to match up one figure and move it to the other. And then when the figures matched up, we also saw it in our congruence activity from earlier this week, where we tried to match up one shape to the other. The sequence of rigid motion transformation, sequence just means more than one or a set of them, one after the other. And rigid motion transformations, we're going to clarify what those are. So that's why I have that at the bottom here. So in case we aren't quite sure which ones are which, rigid motion transformations include translations, reflections, and rotations. So make sure you get those jotted down for me. And we're going to go ahead and go to the next part. All right, so congruent figures. I'm going to ask you guys to draw some triangles. And in theory, if you can make them so they are scalene triangles, so 3 different side lengths, but two triangles that look like they're congruent. I'm going to do my best here. I'll try that one more time. One more quick attempt. So again, attempt to make them look like they're congruent is great. It's okay if it's not perfect. There we go. All right, so I'm going to call this triangle A, B, C. And I'm going to call this one very creatively D, E, F. All right. And so the very first thing I'm going to tell you about these triangles, I said to try to draw them as if they look congruent. So I'm going to say up front that I did all the rigid motion transformations, and I know for a fact if I drew them correctly, that triangle ABC is congruent to triangle DEF. So what that means is that every side from triangle ABC and matches with a side from triangle DEF, and they are congruent. So I'm going to go through and mark them. So I'm going to say segment AC or side AC would have to match up with DF. And in fact, I'm going to write that down. So we have what I'm going to call the sides. So AC, segment AC, is congruent to DF. And then I can say that for AB would have to match up with DE. So AB is congruent to DE. And then finally, my third side, you can name it either way. You could say BC or CB. I'm going to say CB because I like it better. So CB is congruent to FC or FE, excuse me. Now, it is super important as we are looking at this that we match up the letters with the matchy letters. Everything has to be matchy, matchy, matchy. So based on my congruence statement, A has to match with D, B has to match with E, and then C has to match with F every single time in every way when we write things out. So on that last statement I wrote for the sides, I said I wanted to write it as C, then B. So I started at C and moved to B. When I wrote the second part of the statement, then I also started at F and moved to E. If I wrote that in reverse, if I wrote instead CB, and I'll write it just for us to see it for a second. You don't need to write this down. If I wrote CB is congruent to EF, that would be wrong. Even though the side is technically the same length either way, it has to match the picture. They have to go in the correct order. This is a place where geometry is super picky. Okay, so we always have to make sure things go in the proper order when we're talking about congruence. All right, so then we also have the angles. And you can pull them directly from your congruence statement, or you can go back and look at your picture. I'm going to mark them on my picture as we go. So I'm going to say that angle A is congruent to angle D, and I'm going to mark that. A is congruent to D. And then I can say angle B is congruent to angle E, and I'll mark that. And then finally, angle C is congruent to angle F. There we go. All right, and so that sets up kind of the idea of congruent figures. We see all kinds of matchy-matchy parts. We have to keep things in the proper order. All right, so let's take a look at the next one. Given that quadrilaterals JK, LM, and PQRS are congruent, what conclusions can you draw or can you make about their corresponding parts? So this word corresponding, just to clarify, means the matching parts. So what could I say about matching parts like angle J and angle P? I would be able to say they're congruent. If the figures are congruent, all of the parts are congruent. So I would say all corresponding, meaning matching, angles and sides, it's what we just saw in our last little picture, are congruent. Okay? And I could draw that. In fact, I will draw that on my thing here. I'll be super fancy here and draw all the matching angles. And then this one's going to be fun. 1, 2, 3, oopsie, 2, 3, 4. 1, 2, 3, 4. And then I would do that with the sides as well. 1, 1, 2, 2, 3, 3, and 4. Dear heavens. There we go. Okay. So all the sides and all the angles match up and are congruent to each other. Great. So what we call that is all the corresponding parts match up. This is our fancy way of abbreviating it. We call it CPCFC, which is a lot of letters. It stands for corresponding parts of congruent figures are congruent. CPCFC. We're going to use this a lot. So in the classroom, I would make you guys say it over 100 times just to get used to hearing it. CPCFC. Corresponding parts of congruent figures are congruent. It means once we know the figures are congruent, all the parts are also congruent. All right, so we're going to use that concept to answer these questions. We have triangle ABC is congruent to triangle DEF. So we're told right at the top that our triangles are congruent, which means all the matchy parts are going to be congruent. If I go down to example 2, it says find DE. So I want to find DE. I'm going to just trace over it here on the side. So if I want to find DE, I can just look at my pictures, but you got to be careful because sometimes it's deceiving. So I want to be sure. So I look at my congruent statement and I see DE are the first 2 letters, which means they're going to match up with AB, the first 2 letters of the other part of the statement from the other triangle. So then I know for sure that this side AB matches up with DE. So therefore, I can say DE is 2.6 centimeters. In the same way, for example 3, I'm going to find the measure of angle B. So angle B is in the middle, and so it's going to match up with angle E. So angle E on my original figure is over here at 65 degrees, which means that angle B, measure of angle B, would also have to be 65 degrees. And that's it. All right. Then this one, I don't need you to write down in your notes. I need you to I don't need you to write it in your notes. I do want to talk about it though, and we'll go through it quickly. So it says the triangles shown in the figure are congruent. Can you conclude that JK is congruent to QR? And explain. So I want you to think about that and give it your best guess. I'm actually going to talk about this live in class at some point, whether these triangles are congruent. So I want you to have seen it beforehand. JK and QR, do you think that those sides are congruent? We're told the triangles are congruent, so are those sides congruent? Definitely something to think about, and we will come back to that in class at a later point. Okay, so of course we have to make this a bit harder. So now we have a quadrilateral. That's not what makes it harder. What makes it harder is we have expressions instead of just numbers for our sides and our angles. But that's okay. We can use the same concept. Again, starting from the congruent statement, we have GHJK, just kidding, and LMNP are congruent figures. At the bottom, I'm supposed to find LM. So if I look at LM, and here it is on my shape as well, LM right here. There it is. From the congruence statement, I just cannot get that very straight. From the congruence statement, that is going to match up with GH. And I'm going to try to trace those one more time. Well, that one you can barely see it because it's like right on top. Oh, well. All right, so LM is matching up with GH. LM and GH. Okay, which means that even though they don't have a value in terms of a specific number, then we know that those two sides are congruent, so their measures are equal. So I can set up an expression for LM, which is 6x minus 13, and say that that is equal to GH, which is 4x plus 3. At that point, then that's the geometry part of the question. Now I get to practice some algebra. So I'm going to put my x's together by moving the 4x to the other side. So subtract 4x, both sides. I get 2x minus 13 equals 3. And then I'm going to add that 13, oopsie, jumping ahead there, add that 13 to both sides to get the x by itself. Nice inverse operations there. So I get 2x equals 16, and I'm going to move right over here to finish it off. I have 2x equals 16, divide both sides by 2, and I get x equals 8. Now, be super careful, because right there I have x equals 8, but I have not answered the question. The question was to find the length of LM. So then I would go back to my expression for LM, which was 6x minus 13. I'm going to plug in my 8 and figure out what this equals. So 6 times 8 is 48. Minus the 13, I get, looks like 35. So the length of LM equals 35. And that's it. Have a great day, guys.